All right, let's try this example. Here we have two structures for sulfuric acid. Now, if you are drawing sulfuric acid, the Lewis structure, based on your 5 steps, count the valence electrons, put the different one, the least electronegative one, in the middle, as long as it's not hydrogen. Fill the octets of the outer atoms. Then we go ahead, put leftovers on the middle, and make sure that our center has its complete octet. If you were doing this, you would probably end up with structure A, the structure on the left, as your picture. And this is definitely a possibility. This one is a valid structure because we have the correct number of electrons in this picture, and everything that should have an octet does have an octet. However, if you look up online the Lewis structure for sulfuric acid, you're more likely to encounter the structure on the right. Now this structure, what they've done is they took a lone pair from each of the top and bottom oxygens. They swiped from the rich, the oxygen, and shared with the electron poor sulfur. Now, why did they do that? Why does our structure more likely resemble the structure on the right? Let's look at formal charge. Now, if I were going to go ahead and calculate the formal charge for each of the atoms within this structure, let's start with the structure on the left. Hydrogen is supposed to have 1 valence electron. It has half of the electrons in this bond, 1 valence electron. So this hydrogen on the left has a formal charge of 0. The hydrogen on the right is the mirror image of that hydrogen. So this is also a 0, as are both of those hydrogens. 0, 0, 0. Now let's tackle these oxygens. The oxygen here on the left is the same as the oxygen here on the left. This is the same situation, an oxygen with 2 lone pairs and 2 bonds, an oxygen with 2 lone pairs, 2 bonds. Let's do the formal charge for those. This oxygen should have 6 valence electrons minus 1, 2, 3, 4 from the lone pairs, and half of those bonds, 5, 6. 6 minus 6 is 0. So this oxygen, 0 formal charge, as is that oxygen, as is that oxygen, as is that oxygen. Now let's try to tackle the oxygens on the top and the bottom. So on the top and the bottom, they look the same. We have 1 bond and 3 lone pairs. Let's go ahead and calculate those. Oxygen should have 6 valence electrons, and I'm going to go ahead and subtract 1, 2, 3, 4, 5, 6, and 1 from this shared pair, 7. 6 minus 7 leads me to a -1 formal charge. That's going to be the case for the bottom oxygen, and a -1 will be for the top oxygen. Now, what about our sulfur in structure on the structure on the left? For the sulfur on the left, sulfur is right below oxygen. It's supposed to have 6 valence electrons. I'm going to subtract 1 from each of these shared pairs. 1, 2, 3, 4. 6 minus 4 is a +2 formal charge. So this sulfur is sitting very electron deficient at a +2. Notice, overall still, a -1 and a -1, which is -2, and a +2 is 0 overall. Sulfuric acid is neutral, so we're in good shape there, but these are not the most desirable numbers for formal charge. Let's go over to our structure on the right and see what those formal charges are. So I'm going to go ahead and start with the top and bottom oxygen. My oxygens, top and bottom, both have 2 bonds and 2 lone pairs, so they're going to have identical formal charges. Oxygen should have 6 valence electrons, minus, right now, 1, 2, 3, 4, and half of each bond, 5, 6. 6 minus 6 is 0. That is better than -1 formal charges. What about the sulfur though? If we look at our sulfur right here, sulfur should have 6 valence electrons minus half from each of these bonds. 1, 2, 3, 4, 5, 6. 6 minus 6 is also 0. So the structure on the right is a better Lewis structure, having the lowest formal charges possible. Now you notice that sulfur has more than 4 bonds in this structure. Here there's only 4 bonds. Here there's more than 4 bonds. And you need to remember that's okay. Sulfur is in period 3, row 3. So elements in row 3 or below are allowed to expand their octets to have more than 4 bonds. So I hope that helps explain why sulfuric acid has the structure that you see if you were to go ahead and look it up on the internet. I hope that helps. Take care.